Let's learn the introduction to artificial intelligence today. Hey, welcome back to the AI introduction class. In today's video, we've learned about the common algorithms of machine learning. First, we'll look at regression algorithm. Regression algorithm is a mathematical method for dealing with correlation among multivariables. This algorithm is used to analyze statistical relationship between things, focusing on the laws of quantity change among variables. Regressions and classification are different mainly because of their output variables types. Classification output discrete labels, while regression output continuous numerical values. Many algorithms have both regression and classification versions. In this part, we will see the commonly used algorithms in regression analysis. Regression analysis focus more on analyzing, which means it's more about the model's interpretability. In other words, after training model, we can clearly understand the impact of each feature or attribute on the target variable and obtain quantitative and intuitive data. This is a very important technique in the field of data analysis. In regression analysis, the commonly used algorithms include linear regression, logistic regression, polynomial regression, stepwise regression, ridge regression, lasso regression, and elastic regression. These regression algorithms have wide applications in scientific research and business data analysis. For example, in the business of predicting interaction volume in Sina Weibo, we can sample some content producers and use their interaction behaviors on their Weibo, such as the number of reposts, comments, likes, and so on, to build a regression model and control the distribution of the posts. And then we can apply the built model to other content producers to achieve the prediction purpose. Cluster algorithms are unsupervised learning algorithms used for classifying samples with unknown labels. There are 5 basic types of cluster algorithms. The first type is partition-based clustering algorithm, which divides data into long overlapping subsets who represent clusters. The common examples include the k-means algorithm. The second type is hierarchical clustering algorithm. It computes the similarities or distance between each data point and gradually groups similar data points into a hierarchical clustering tree until all data points are classified. The common examples include agglomerative and divisive hierarchical clustering. Density-based clustering algorithm is another kind method which identifies clusters by partitioning dense regions in data. Common examples include DB-scan and OptiX. Grade-based clustering algorithm divides data space into grades and clusters data in each grade units, and then merges Johnson's units of the same class. Common examples include Pleak and Stain. The fifth type is model-based clustering algorithm. It groups data by using mathematical models and statistical methods. The common examples include GMM and HMN. These algorithms can be used for clustering large data sets into meaningful groups without prior knowledge of data labels or patterns. When we use clustering algorithms, there are several points to keep in mind. First, we need to consider the scalabilities of the algorithm. Some algorithms are suitable for handling small datasets, but becomes very time-consuming when processing large datasets. So we need to choose the appropriate algorithm to match the datasets and business objectives. Secondly, we need to consider whether the algorithm is suitable for data type being processed. Most clustering algorithms are only suitable for numerical data. For category data, we need to consider data type conversions or choose a suitable algorithm. Thirdly, we need to consider whether there are any spatial requirements for the shape of clusters. Some algorithms can only obtain spherical clusters. If we need to explore clusters of arbitrary shapes, we need to choose another algorithms. Firstly, clustering algorithm parameters are difficult to determine and requires multiple exploration and some indicators to determine. Firstly, we need to consider whether the algorithm is sensitive to noise data. Sixthly, we need to know whether the algorithm is sensitive to initial inputs. Some algorithms may get stuck in local optimal solutions and cannot obtain global optimal solutions. And then, whether the algorithm is suitable for high-dimensional sparse data. Finally, we need to consider the interpretabilities of clustering results and whether clustering needs to be performed under certain constraints. Now we move on to dimension reduction. Dimension reduction algorithms are a technique to convert high-dimensional data into low-dimensional data. They can be used to compress data, reduce computation, remove noise, and improve the accuracies of classification and regression. Linear dimensionality reduction algorithms, like PCA, transform the original data into a new coordinate system. And by keeping the most important principal components, they reduce the dimensions of the data. Long linear dimensionality reduction algorithms map the data to a lower dimensional. These algorithms are widely used in various fields, including image processing, signal processing, natural language processing, and genomics. Decision tree algorithm is a type of machine learning algorithm that helps us to make decisions based on input data. It uses a tree-like model to sort the data into smaller groups based on their characteristics and then create a model that predicts the outcome based on those groups. Decision tree can be used for classification and regression problems. By analyzing the data and building decision trees, we can make better decisions and predictions. They are applied in various fields like medical diagnosis, financial risk assessments, and marketing. Bayesian algorithms is a type of statistical algorithm that use Bayes' theorem to make predictions or decisions. It involves updating a prior belief or probability based on new evidence or data. It's particularly useful in situations with limited data and high uncertainty, where it can provide a way to reason about probabilities and make informed decisions. Support vector machines is a powerful algorithm used for classification and regression analysis. It works by finding the optimal hyperplane that separates the data into different classes with maximum margin. The hyperplane is chosen such that it maximizes the distance between the closest points from each class, which are called support vectors. SVM can handle both linear and nonlinear datasets by using different kernels to transform the input data into a higher dimensional space. SVM have wide applications in fields such as image recognition, text classification, and bioinformatics. Association rules mining is a data mining technique used to identify associations or correlations between different items in a dataset. The algorithm aims to find patterns that occur frequently in a given dataset by exploring all possible combinations of items and identifying those that occur together more often than would be expected by chance. The most popular association rules algorithms is the a priori algorithms, which generates frequent item sets by interactively scanning the datasets, and the pruning infrequent item sets. Once frequent item sets are identified, The algorithms generate association rules by computing the support and confidence of each possible rule. The support of the rule measures the frequency of an item in the rules of the dataset, while the confidence measures the proportions of transactions containing the antecedent item that also contains the consequent item. The algorithm then selects rules that meet a user-defined minimum support and confidence threshold. Association rule math has many practical applications, including market basket analysis, recommendation systems, and fraud detection. By identifying patterns and correlations between items, business can optimize their marketing strategies and increase customers' engagement. Genetic algorithms are a type of optimization algorithms inspired by the process of natural selection. They are commonly used to find the best solutions into a problem by repeatedly generating and testing the candidate solutions. The basic idea is to start with a population with randomly generated solutions and then apply a series of genetics operations such as a selection, crossover, and mutation to produce new candidate solutions. These new solutions are then evaluated and select for further breeding based on how well they perform on new problems. Over time, the genetic algorithms converges towards the best solution in the population, as the fittest individuals are more likely to be selected for breeding and pass on their genetic information to the next generation. Genetic algorithms can be applied to a wide range of problems, including optimization, machine learning, and simulation. They are particularly useful in cases where search space is large and the optimal solution is difficult to find using traditional methods. Alright, so that's what we need to know about the common algorithms in machine learning. In this class, we'll be getting to neural network,